Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we're Backyard Musings Science and Technology Channel.
Yep, and we were talking about a topic today that we don't haven't touched too much on the old dinosaurs, but today we're going to talk about one, probably everyone's favorite, or maybe least favorite.
This story captured my eye, so hopefully you'll find it interesting too. Triceratops' enormous nose may have been a built-in cooling system for its massive head. You know how elephants have those massive ears to help cool down?
Right.
Maybe the same thing. Triceratops and other horned dinosaurs had remarkably large nasal cavities compared with most animals. To understand what filled that space, researchers, including a team from the University of Tokyo, examined CT scans of fossilized Triceratops skulls and compared them with the snouts of living birds and crocodiles. Would you like to know more?
Okay, so University of Tokyo. I wonder why we're not talking about Godzilla.
Gojira.
Yeah. All right. Be careful. By carefully studying the bones and drawing on knowledge of modern reptiles, they reconstructed how nerves, blood vessels, and air passages were arranged inside the skull. Their analysis suggests that these dinosaurs relied on their noses for more than detecting smells. The oversized nasal system likely helped regulate heat and maintain moisture. Not to mention make them look pretty scary.
So. Yeah. If you look at that picture on the screen right now, I'm just looking at those eyes almost directly underneath the horns.
Yeah.
That's weird.
It is weird.
Huh.
Yeah.
And then that big mouth is all for plants. It's an herbivore.
Yeah.
Like a rhino, I guess. Crazy.
Yeah.
All right. Imagine encountering a Triceratops and asking, aren't they extinct? Followed by, why does it have such an enormous head? That second question intrigued project research associate Shishiro Tada of the University of Tokyo Museum as he examined a specimen, a fossilized one. Quote, I've been working on the evolution of reptilian heads and noses since my master's degree, he said. Triceratops in particular had a very large and unusual nose, and I couldn't figure out how the organs fit within it, even though I remember the basic patterns of reptiles. That made me interested in their nasal anatomy and its function and evolution. What a strange, yeah, I want to check out the nasal anatomy of a Triceratops,
Yeah. I don't know. Dinosaurs displayed a wide variety of skull shapes, adding to their striking appearance. Among them, horned dinosaurs known as Ceratopsia developed especially elaborate head structures, and Triceratops remains one of the most recognizable. Despite its fame, scientists still have limited knowledge about the soft tissues that once filled its skull. Tada and his colleagues set out to reconstruct those missing internal features using advanced imaging tools. Would that be like an AI?
Probably.
Yeah, a little AI, a little computer drafting or computer design or whatever. Yeah, very cool.
Quote, employing X-ray-based CT scan data of a Triceratops, as well as knowledge on contemporary reptilian snout morphology, we found some unique characteristics in the nose and provide the first comprehensive hypothesis on the soft tissue anatomy in horned dinosaurs, he said. Triceratops had unusual wiring in their noses. In most reptiles, nerves and blood vessels reach the nostrils from the jaw and nose, but in Triceratops, the skull shape blocks the jaw route. So nerves and vessels take the nasal branch. Essentially, Triceratops tissues evolved this way to support its big nose. I came to realize, this is still a quote, I came to realize this while piecing together some 3D printed Triceratops skull pieces like a puzzle.
Huh. The researchers determined that the structure of the skull redirected nerves and blood vessels along a different route than seen in most reptiles. Instead of traveling through the jaw, those structures pass through the nasal region. This arrangement appears to have evolved to accommodate the dinosaur's exceptionally large snout.
So we've got a picture of a Triceratops skull on the screen right now, and that thing is long.
Yeah.
That's crazy, isn't it?
Yeah. So it had some kind of a like a fan or something behind its horns, though, didn't it? Or maybe it was just the bone. Is it that bone that's behind it? You can see next to that man's head.
Yeah, that's the bone. I don't know what to call
Obviously,
it.
that was covered with skin and meat, right? So maybe that's what I'm thinking of.
Well, skin, yeah, but I don't know about meat because what would be up there to serve a function? What would it do? I mean, I could see skin.
Yeah, I don't know. But I remember that seeing pictures in cartoons or movies or whatever where the thing had some kind of a protection or a fan behind it. Maybe that's what it was for. Maybe it was to help protect its body from when it was attacked.
Like we have skin over the skull, that's all our skin over the skull does is covers the skull.
Right.
And hair grows from it. Maybe hair grew from that.
Yeah.
Interesting. The team also identified evidence of a structure called a respiratory turbinate inside the nose. Few dinosaurs are known to have had this feature, but birds, which are living descendants of dinosaurs, possess them, as do mammals. Respiratory turbinates are thin, curled structures within the nasal cavity that expand the surface area available for blood and air to exchange heat.
Although Triceratops was probably not fully warm-blooded, these structures may have helped regulate temperature and conserve moisture. Given the size of its skull, shedding excess heat could have been challenging. The presence of respiratory turbinates suggests its nasal cavity played an important role in maintaining stable internal conditions.
Quote, although we're not 100% sure Triceratops had a respiratory turbinate, as most other dinosaurs don't have evidence for them, some birds have an attachment base, a ridge, for the respiratory turbinate, and horned dinosaurs have a similar ridge at the similar location in their nose as well. That's why we conclude they have the respiratory turbinate as birds do, said Tata. Continuing his quote, horned dinosaurs were the last group to have soft tissues from their heads subject to our kind of investigation. So our research has filled the final piece of that dinosaur-shaped puzzle. Next, I'd like to tackle questions around the anatomy and function of other regions of their skulls, like their characteristic frills. I don't know what characteristic frills he's talking about.
Yeah.
But it sounds interesting.
But you mentioned at the beginning that these things eat plants and vegetables. I mean, they're green eaters, right?
Yeah.
So obviously the horns had to be there for protection. From, So they weren't using that to kill anything to eat it, because all they eat is plants. So
just like steers and minotaurs have horns for protection.
Gotcha. Okay.
We should do a segment on minotaurs. That'd be cool. Or centaurs.
Okay. Well, hopefully our producers will be able to find something. All right, everyone.
Hey, folks, we hope you enjoyed this. It was interesting.
Yep. We'll see you in the afternoon. Take care.